Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is HVAC systems for pharmaceutical manufacturing. The basic understanding. HVAC stands for heating, ventilation and air conditioning. HVAC is a coined abbreviation for handling the system of heating, ventilation and air conditioning. This system is necessary when there is a requirement to control the air quality and room temperature in the closed and controlled room operations. HVAC is all about temperature and air control system. HVAC is all about handling of air circulation and control of temperature in closed rooms. Such closed rooms are called clean rooms. These rooms are classified according to the product requirements. Common classification is 100,000 classification for non-sterile products. Tighter classifications like 10,000, 1,000 and 100 may be required for aseptic sterile conditions. The intent of HVAC is to control the surrounding environment where individual equipment tray cannot be operated in closed condition and there is a possibility of product being exposed to outside atmosphere. There are some of the plant equipment located outside in semi-controlled areas without any contamination of the product within the equipment. This is because the product being processed is contained within the equipment like reactor and not exposed to uncontrolled atmosphere. As the process moves forward towards the final product, there are possibilities that the product may get exposed to outside atmosphere. Examples include unloading after drying operation, milling, sifting and packaging activities. In such activities, it is necessary to control the surrounding atmosphere to protect the product from contamination. It is something like traveling on the road on a hot summer day. You control the temperature of your car for comfort. You cannot control the heat outside the car. So your car is considered as a closed room. Also, it is a temperature classified room. You set a temperature of less than 25 degrees Celsius for comfort and the air conditioning system of the car maintains the required specifications. Also, when there is impact on the quality of the product with uncontrolled humidity and temperature conditions, HVAC plays important role in pharmaceutical manufacturing. There are several products which are sensitive for temperature and humidity. It is particularly important when hygroscopic products are handled. So, the HVAC should be designed to control the temperature and humidity also. The specifications depend on the product being manufactured. A well-designed HVAC system will also provide comfortable conditions for operators. Along with the product, the operator is also present in the closed rooms involving in several process operations. Unless there is effective air circulation, the operator gets suffocated in the closed rooms. So, the HVAC system is to take care of both the product and comfort of the operator. Let us look into the design aspects. The three primary aspects addressed for the HVAC system are product protection, personal protection and environmental protection. As discussed above, in addition to the protection of product, comfort to the operator, protection of environment is also important aspects of HVAC systems. Risk assessment has to be carried out for optimum design addressing all the three above requirements. Prevention of contamination and cross-contamination should be the essential part of design considerations. Risk assessment should be conducted in a detailed way. It is necessary to have a team of structural engineers, air handling experts are required for getting an effective operating design. Process engineers, product specialists who have full knowledge of the process requirements and product requirements also should be the part of the team. As discussed on several occasions, the ICH Q9 guide is a wonderful guide to assess the risk. FMEA or FMECA, HACCP, HAZOP and PHA tools will work effectively for the evaluation. The design should have adequate personal airlocks, material airlocks, pass-through hatches, change rooms and passages. So the risk assessment would provide basis for these airlocks, change rooms and passages. Let us see air controls. By principle, the surrounding environment should be controlled. It means the air and humidity should be controlled by HVAC systems. By now we got good understanding on the basic principles of HVAC systems. Let us now look into the air controls. So in closed rooms, effective flushing with fresh air is required for comfortable working conditions. Also, too much humidity in closed rooms would suffocate the operator, and of course the product quality also will be impacted for inappropriate humidity conditions. Temperature control is also necessary for the air coming into the closed rooms. The design should include supply and return of air and its quality. Obviously, for effective flushing, there should be air inlets for fresh air and air outlets for flushing out the contaminated air. There are two basic concepts of air delivery to pharmaceutical production facilities: a recirculation system and a full fresh air system, that is 100% outside air supply. Depending upon the product requirements, a recirculation system or a full fresh air system may be used. Mostly a recirculated system are used when the temperature and humidity inside the closed room is very important to control. Also, it saves a lot of electrical power energy. Also, when the product is very potent and highly sensitive in very low dosages, and if it is vented out, the environment gets contaminated. There could be other reasons also for selection of particular type of system. The risk assessment should provide necessary supporting data for all these things. Appropriate pressure differentials should be made depending upon the product requirements. Different pressures at different locations are as required by the product requirements. We will discuss in coming up slides on the aspect of pressure differentials. Let us understand how a recirculation system works. The intent of this system is to recirculate air through inlets and outlets. The inlet air should supply always clean air. Contaminated air should be filtered for getting fresh air again through inlet. This can be achieved by installing a HEPA filter at the inlet. Depending upon the impact on the product quality, selection of HEPA may be made. Return air ducting may also be fitted with appropriate filter to avoid excessive load on HEPA filter in the air handling unit AHU. This should be a part of risk assessment report. The position of inlets and outlets should be designed for effective room flushing. Low level return or exhaust air grills are usually preferred. However, where this is not possible, a higher air change rate may be needed to achieve a specified clean room area condition. Example, where ceiling return air grills are used. If there is adequate provision, it is always preferable to have the return air outlets at lower levels. If the return air duct is located at higher levels, you may have to go for higher air changes. Air changes per hour is a simple calculation. Air change rate is a measure of the air volume added or removed from space in 1 hour divided by the volume of the space. The calculation is simple. Measure the area of the room, measure the height. This would give you the volume of the room depending upon the capacity of the blower, which is generally given as cubic feet per minute. Multiply with 60 for getting the results per hour. Then divide the figure with the volume of the room. You get number of air changes per hour. Approximately 10 to 20 is comfortable number. Let us see one typical example of recirculation system. In this drawing, we have two clean rooms with inlet filters and outlet filters. The outlet filters are located on the lower side of the room. You have a air handling unit which pumps fresh air into the room for effective flushing, and the return goes back to the air handling unit for filtration and recirculation. In this design, you have some amount of fresh air also taken into the air handling unit. The HEPA filter may be within the air handling unit or it can be in the terminal depending upon the risk of contamination of the product. Let us see how fresh air systems work. This is also called as ventilation system. In this system, degree of filtration depends on exhaust air contamination. There are environmental regulations for levels of such contaminants to pump out into atmosphere. This system is also sometimes referred as once-through system. Higher levels of filtration may be required if the exhaust air is beyond the limit of regulations of the environmental agencies. This system is recommended when there are toxic products or solvents handled in closed rooms. This is used for toxic and highly potent products and solvents. In such systems, the relative pressure between the supply and exhaust air system should be such that the exhaust air system operates at a lower pressure than the supply system. This point prescribes that the exhaust should be at lower pressure compared with inlet pressure. That means the exhaust should work slower than the air supply. The risk assessment should decide on the pressure rating of inlet air and exhaust air. Air filtration and air changes rates should be set to ensure that the defined room conditions are attained. Let us see one example for fresh air system. As in the previous example, there are two clean rooms with inlet filters and outlet exhaust filters. You have a air handling unit inlet which has a filtered air which is pumped into the clean rooms for effective flushing, and the return after the return filters goes to the AHU outlet which sends out into the atmosphere. As in the previous design, the HEPA filter may be in the terminal or in the inlet AHU also. Depending upon the type of product, it may be necessary to have some filters in air handling unit outlet also. Let us see other important aspects of HVAC systems. Basic criteria to consider include building finishes and structure, dust control and containment, air filtration, air changes or flushing rate, airflow pattern, room pressure, location of HEPA filters, temperature and RH, man and material flow, clean area gowning procedures, equipment movement, open or closed process, occupancy, quality of external air, etc. Even though the finer details of the information of this slide are not within the scope of this brief video, all these aspects have to be considered while designing the HVAC systems. A detailed risk assessment report should provide answers to all the above list of aspects. A detailed risk assessment would definitely provide answers to all these important aspects. Let us see the types of airlocks. By definition, a lock is one which prevents unwanted entry of anything. Airlock is a lock between two clean areas with a definite design to avoid contamination. There are three types of airlocks. Depending upon the process and product requirements, suitable airlocks will be designed. Let us try to understand the types of airlocks and its functionality. If the intent of each design is understood well, you get fun in the subject. The three types of airlock systems are Cascade airlock, sink airlock and bubble airlock. Let us see one typical example of Cascade airlock system. In this example, the passage, airlock room and core room of clean area are considered. The passage is at 15 pascals, the airlock room is at slightly higher at 20 pascals and the core room is still at higher 30 pascals. What is a cascade? It is one pass on to a succession of others. In this example, any leak, air leak from 30 pascals will go automatically to lower 20 pascals and subsequently to still lower 15 pascals. The flow is from higher to lower and further to least. This is exactly the meaning of cascading effect. In this design, the core is at higher pressure and any leakage would be into the airlock room. Similarly, any leakage from airlock will lead to passage. So, the airlock protects the core by taking the leak outside to the airlock and to further passage. In this design, the contamination from passage to the core is not possible. So, the core is the safest area from contamination. Another point here is that the doors of airlock opens to more positive side. See this design. The concept is simple to understand. The door will try to keep in closed condition always because of the pressure exerted on the doors. If the doors open to the lesser pressure areas, the doors would tend to open under higher pressure. I hope it is not too complicated to understand this simple principle. Let us see an example of sink airlock system and how it works. As in the previous example, the passage, airlock room and core room is considered for this. The passage and core room are maintained at 30 pascals, whereas the airlock room is maintained at 15 pascals, less than the passage and core room. What is a sink? A sink takes everything into it. See this example. Leakage from core and passage goes into the sink, the airlock. This design would suit for high potent drugs which may contaminate the passage in the Cascade airlock system. In this design, the passage is protected and the contamination is contained within the airlock. The airlock can be cleaned individually once the process is complete. Same principle for opening the doors. Opens to the positive pressure side. Let us also see an example for bubble lock. As in the previous example, the passage, airlock room and core room are considered. In this design, the airlock room is maintained at higher pressure of 30 pascals, whereas the passage and the core room are maintained at lower pressure of 15 pascals. What is a bubble? When it leaks on to both the sides. Like if a bubble blows off, the air inside will push everything out. This design is similar to it. This design suits well if there is more men movement and material movement along the passage, which could contaminate the product in the core area. The same principle of the opening of the doors open to the positive pressure side. Let us look into some important definitions. As built condition, that means this state is where the infrastructure is ready with air handling systems and ready for installation of process equipment in it. That means building and facility is ready by this. The only pending item is the installation of equipments within the building. At rest condition is this state is after installation of necessary equipment for operation for the particular process. Operational condition is this state is when the process starts with operation of equipment and men movement in the process. By this, the routine operations would start. The system may have to be qualified for all these three stages fully. Let us see the different types of grills used for different types of air patterns in clean rooms. For turbulent flow, perforated grills would give this type of flow pattern from the air inlet. For induction flow diffuser, ventilator type grills would give this type of flow pattern. For swivel flow diffuser, fixed circular swivel diffusers would give this type of flow pattern. Air handling system is a very vast subject. The intent of this video is only a brief introduction to basic understanding of certain terminology used for HVAC systems. I hope the content and the intent of this video is understood well. For more elaborate data, please refer WHO TRS 1019 Annex 2 guideline. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.